So, Bridget, we're going to try to help you out with some word problems involving integers, numbers. So I'm pulling some of your examples up. For the most part, a lot of your thinking's right on the money. I think some of it's just some careless mistakes here and there. Let's just take a look at some thought processes here. Your first example that you said you had some trouble with. 3 times the sum of a number and 5 is equal to twice the number plus 5. Find the number. So again, what you're trying to do is trying to write an equation. But before I can really write an equation, I have to really understand how this information works. And for me to understand how that information works, I need to make it a little bit more concrete. So I like to pick values for x and trial and error them. So we know what we have to find is we have to find this number. So we know that x is going to represent this number. So in doing so, what I'm going to do is just trial and error to start with. And I want to just pick a number that is kind of useful to me. So I like I said, 2s and 5s, things that I can kind of play with pretty easily without a whole lot of thinking. So 3 times the number. Well, let's just suppose x is equal to 10. Now, I don't know if that's the right number, but I'm just going to start with a number that I can kind of play with. So if x equals 10, what I can look at is 3 times the sum of a number and 5. Well, so what I'm picking up on is I've got to multiply 3 times the sum of a number and 5. Well, I'm saying that number is 10. So 10 plus 5, I have to add those together, and then I've got to multiply that by 3. So, and that has to equal twice the number, so that means I have to go 2 times 10 plus 5 more. So I'm coming up with that kind of statement here. So 3 times some number plus 5 has to equal 2 times some number plus 5. So there's my equation. Now I'm going to see if 10 actually worked. For 10 to work, this has got to be a true statement. If it's not a true statement, then 10 wasn't my solution. So I know order of operations, I have to go 10 plus 5. That's going to give me 15. Equals 2 times 10 is 20. And 20 plus 5. So I'm going to get like 45 is equal to, say, 25. So I'm picking up on that 10 is not the right number. But it is picking up on some concreteness. I do understand that wherever there's a 10, that also represents where x has got to be. So what I can do then is, using that information, I can put it together and write an equation. So I'm picking up on 3 times the quantity x plus 5 is equal to 2 times x plus 5. That should look very similar to what you wrote down. I think you may have used n, I'm using x, but the same concept. Now remember, to remove these parentheses, you have to use the distributive property. You have to multiply that 3 through the parentheses. So that's going to be 3 times x plus 3 times 5, which is 15, is equal to 2x plus 5. From here on out, it looks like your equation strategies are really good. You can probably work this out without me doing anything. You kind of zero out the smaller guy. I pick on the little guy. I put the negative 2x there. I get x plus 15 is equal to the 2x, negative 2x, 0 out. I get a 5. And to get rid of the 15, I can use a negative 15 there to get that zeroed out. And I have x equals then 5 and a negative 15 gives me a negative 10. So what they're saying is negative 10 should be the solution. If I check that, 2 times negative 10 plus, 3 times the sum of negative 10 and 5 has to equal 2 times negative 10 and 5. So negative 10 and 5 gives me a negative 5, so that's going to be 3 times a negative 5. And this is going to be a negative 20 and a positive 5. 3 times negative 5 is indeed a negative 15. And negative 20 and a 5 is a negative 15. So it does check out. So that indeed is going to be our solution to the problem is x equals negative 10. And I believe you had that one set up right. I think you just had a small mistake on that one. Stay tuned. I will send another video to you.